Top-down design is a process to break down a large task into smaller, more manageable subtasks. Each subtask is implemented as an independent module. It is a design of modular programming. For example, we have a task here, and we're going to break it down into 3 subtasks. The task will be accomplished as long as the 3 subtasks are accomplished. The solutions to each subtask should be independent to each other. This is very important because if we later find a better solution, for example, to task 2, we can just make changes to task 2. And there's no need to change the solutions to task 1 and task 3. And this makes the design more robust and easy to maintain in the future. If this level of breakdown is not sufficient enough, you can continue to do so to break it down to the second level, the third level, or the fourth level, until to the level that you feel comfortable to manage the subtask. MATLAB function is an independent module that can accomplish one specific task. It has the defined input data list for the only data entry to the module and the output data list for the only data exit from the module. This is very important. It is a guarantee that the MATLAB function is an independent module. The internal code of a function can be revised. As long as the input and output data lists are not changed, the revision will not affect the integrity of other code. This is the independence of the MATLAB function. Finally, MATLAB script is a tool to integrate those independent modules. It serves as a glue to put all those modules together. This is an example of top-down design. Here we have a noisy sinusoidal signal. What we're going to do is to find out the frequency of the sine signal. We break down the tasks into 2. First, we will remove the noise and to get the clean data, and later we're going to use the clean data to measure the frequency of the signal. This is a solution to the task. What we're going to do is to find the frequency of the noisy sine wave until there is no more input data. This is a pseudocode. In the pseudocode, we break the task into 2 subtasks. The first subtask is to suppress the noise in the data using the smooth filter. The second subtask is to retrieve the frequency from the clean data using the frequency detector. At this point, we don't care how the smooth filter and the frequency detector are implemented. We just assume that the 2 modules are available for us to use. Now, we're going to use a while loop to put these 2 modules together. So the while loop will first check if there's any more data. If so, it will do the 2 steps. And once it finishes the 2 steps, it will go back and check no more data again. If there's no data, then it stops processing. Here is the flowchart. So first it will check if there is any data. If there is, then we are going to use a smooth filter and frequency detector to find the frequency of the signal. Otherwise, we just exit the loop. Now, please keep in mind that the input data to the smooth filter is the noisy data, and the output is the smooth data. For the frequency detector, it needs the smooth data as the input, and it will output the frequency. Later, we will find another solution to remove the noise. Then what we're going to do is just to replace the smooth filter with other filter. Here is another scenario of the task. In this case, the noise is very specific to be the 60 Hz interference. At this point, the smooth filter may not work well. What we're going to do is to use something called a notch filter to clean up the data. The notch filter is designed to remove a specific frequency from the signal. The updated solution will look much similar to the previous solution. Here is the pseudocode. When you check the pseudocode, you will see that the only thing changed is the filter in the first module. So instead of using the smooth filter, we use a notch filter. And we will have the similar flowchart, but in this case, the smooth filter will be replaced by the notch filter. As long as the notch filter will produce the smooth data, then the frequency detector will use that data to find out the frequency. And there is no need to change the code inside the frequency detector.